We're going to look at how to do problem involving limiting reagent. So the idea behind a limiting reagent can be shown with this sandwich deal right here. If you had two pieces of bread and one piece of cheese, you could make one of these cheese sandwiches right here. So if we had three pieces of bread and we had one piece of cheese, then you could make one sandwich, one product, and you'd have one piece of bread left over. So what we didn't have, well, here, let me add one more piece of bread right here. Now we have enough bread to make two sandwiches, but we only have enough cheese to make one sandwich. So we could say that cheese is the limiting reactant or the limiting reagent. We don't have enough cheese to go with this amount of bread. We have too much bread to go with this amount of cheese. So we could say that bread is the excess reactant or the excess reagent. So we'll look at this with a stoichiometry problem now. When copper 2 chloride reacts with sodium nitrate, copper 2 nitrate and sodium chloride are formed. So the first thing we're going to need to do is write a balanced equation for the reaction. So we got copper 2, which has a charge of 2 plus, so we're going to need 2 chlorides. And then we've got sodium nitrate, and sodium has a 1 plus charge, and nitrate has a 1 minus charge. So they're at a 1-to-1 ratio, and they're going to react to form copper 2 nitrate. We're going to need 2 nitrates to go with that copper 2 and sodium chloride. So it says if 15 grams of copper 2 chloride react with 20 grams of sodium nitrate, how much sodium chloride can be formed? So they're saying that we have 15 grams of this copper 2 chloride and we have 20 grams of this sodium nitrate, and it's asking us how much of this sodium chloride can be formed. So what we're going to do is first we're going to see how much sodium chloride we can make with 15 grams of calcium chloride. So we're going to go like this first. And then the second thing we're going to do is we're going to figure out how much sodium chloride can be made with 20 grams of sodium nitrate. So we're going to do that second, like that. So first, we're going to start with 15 grams of copper 2 chloride. And we're going to multiply that by 1 mole of copper 2 chloride. And then the molar mass of copper 2 chloride is 134.45 grams, according to my periodic table. And then we're going to multiply that by the mole ratio. So we don't have that yet because we haven't balanced this. And that's why it's important to balance these chemical equations. So we got 1 copper here, 1 copper here. That's good. We got 2 chlorides and 1 chloride. So I'm going to need to put a 2 there. We got 1 sodium and 2 sodiums. So I'm going to have to put a 2 there. Then we have 2 nitrates and 2 nitrates, so everything's good. So if we look at the mole ratio between sodium chloride and copper 2 chloride, it looks like 2 to 1. 2 moles of sodium chloride for every 1 mole of copper 2 chloride. Then we're going to multiply that by the molar mass of copper 2 chloride, which is of sodium chloride, which is 58.44 grams per 1 mole of sodium chloride. And then if I do this divided by this, times this, I get 13.03 grams of sodium chloride. So if we have 15 grams of copper 2 chloride, we can make 13.03 grams of sodium chloride. Second, I'm going to figure out how much sodium chloride can be made with 20 grams of sodium nitrate. So I'm going to start with 20 grams of sodium nitrate, and I'm going to multiply that by the inverse of the molar mass, which is 134.45 grams of sodium nitrate. Okay, and then it looks like there's 2 moles of sodium chloride for every 2 moles of sodium nitrate. And then we're going to multiply that by 58.44 grams of sodium chloride per 1 mole of sodium chloride. And then I'm going to do 20 divided by 134.45 times 2 divided by 2 times 58.44, which is going to give me 13.75 grams of sodium chloride. Now, both of these can't be right. If we mix 15 grams of copper 2 chloride with 20 grams of sodium nitrate, we're either going to be able to make 13.03 grams of sodium chloride or 13.75. If we go back to the sandwiches, we'd realize that the smaller number is correct and the bigger number is incorrect. So we can actually make 13.03 grams of sodium chloride. So the limiting reagent for this reaction, we're talking about a reagent, not a product. So we're going to have to go back to see what reagent gave us this amount. And it was copper 2 chloride. So copper 2 chloride was the limiting reagent. What that means is that's the chemical that we're going to run out of first. So we're going to be able to use 15 grams of copper 2 chloride. We're not going to use all 20 grams of this sodium nitrate. Some of this sodium nitrate is going to be left over. So next it asks how many grams of copper 2 nitrate is formed. So we figured out how much sodium chloride is formed. It's next asking how much copper 2 nitrate is formed. So what you're going to do for that is you're going to do a gram-to-gram stoichiometry problem going from your limiting reagent to this product that you're interested in next. So do a gram-to-gram stoichiometry problem going from 15 grams of copper chloride and figure out how much copper nitrate you can make with that. Okay, so it looks like we're able to make 20.93 grams of copper 2 nitrate. Now, it's important to realize that you need to start with the limiting reagent here. If you started with this 20 grams of sodium nitrate to figure out how much of this copper 2 nitrate you could make, you'd get a number bigger than this, and it would be a lie. Okay, next it asks how much of the excess reagent is going to be left over in this reaction. So excess reagent means leftover ingredient. So 20 grams of this sodium nitrate